Let's try a few of these tricky ones. So in this case, we're going to divide by the highest power of x in the denominator. So this is going to be the limit as x approaches infinity of the square root of 3x squared plus 3 divided by x over 2x plus 5 also divided by x. And now we're going to cancel some x's in order to find this limit. This is the limit as x goes to infinity of 2x over x, which is just 2, plus 5 over x in the denominator. And now for the numerator, we want to bring this x under the square root sign. So we're going to write it as the square root of x squared, and since x is positive, then x is equal to the square root of x squared. So the square root of x squared is always equal to the absolute value of x. The numerator becomes the square root of 3x squared plus 3 over the square root of x squared. And now I can amalgamate this into one square root sign. So this is the limit as x approaches infinity of the square root of 3x squared over x squared. So that's just 3 plus 3 over x squared. So it's bringing that square root of x squared under the square root sign. And the denominator is as before, it's 2 plus 5 over x. Now as x approaches infinity, we have this goes to 0, this goes to 0, and this limit is equal to the square root of 3 over 2. So for this function, we have a horizontal asymptote of the form y equals the square root of 3 over 2. Now we may have a different horizontal asymptote as x goes to negative infinity if this limit exists. So again, we divide by x in both numerator and denominator. And as x approaches negative infinity, this limit is the same as the limit of 3x squared plus 3 divided by x over 2x plus 5 divided by x. And now the denominator is easy to take care of. This is the limit as x approaches negative infinity of 2 plus 5 over x in the denominator. And now in this case, x is negative, so x is equal to minus the square root of x squared. So this x here gets replaced by minus the square root of x squared in this expression. And this is equal to the limit as x approaches negative infinity. Now amalgamating the square root, it's negative 3x squared plus 3 over x squared all over 2 plus 5 over x. And this is equal to minus the limit as x approaches negative infinity, that's pulling that minus out to the front, of the square root of 3 plus 3 over x squared all over 2 plus 5 over x. Now of course this is going to 0 and that's going to 0, and this is negative the square root of 3 over 2. So this function, which is the same as this one, also has a horizontal asymptote of the form y equals negative the square root of 3 over 2, since the limit as x goes to negative infinity of the function is equal to minus the square root of 3 over 2. And of course it has a vertical asymptote at x equals negative 5 over 2, where the denominator equals 0, since this value of x doesn't make the numerator equal to 0. Now you can imagine what the trick is to evaluate this limit. First of all, as x approaches infinity, this part goes to infinity and this part goes to infinity. So it's infinity minus infinity, and we have two different forces working on it. This infinity is increasing the value of the function, and this negative large number is decreasing it, so we can't tell which of these two forces win. So this is an indeterminate form. And so we must somehow reshape the function in order to figure out this limit. And you can imagine what we're going to do. We're going to multiply by the conjugate so we can get rid of these square roots. So it's the limit as x approaches infinity of all of that times the conjugate, which is the square root of x squared plus x, plus the square root of x squared minus 2x, divided by square root of x squared plus x, plus the square root of x squared minus 2x. Now this is of the form a minus b times a plus b, and of course that becomes a squared minus b squared. So this is equal to the limit as x goes to infinity of a squared, which is x squared plus x, minus b squared, which is minus x squared minus 2x, all over the denominator here, which is the square root of x squared plus x, plus the square root of x squared minus 2x. Now some things cancel here. The x squares go away, and we're left with the limit as x goes to infinity of x minus minus 2x, so that's 3x, over the square root of x squared plus x, plus the square root of x squared minus 2x. Now as x approaches infinity, the numerator approaches infinity, and so does the denominator. So again we have an indeterminate form. And we can use our previous trick. We can divide by what's roughly the highest power of x in the denominator, which is the square root of x squared. We can divide both numerator and denominator by x, and then the leading terms in the denominator should not have an x in them. So this is equal to the limit as x goes to infinity of 3x over x over the square root of x squared plus x, plus the square root of x squared minus 2x all over x. And again, I'd like to bring this x under the square root sign, because the x is positive. X is the square root of x squared. And of course I can cancel the x's here. So this is the limit as x approaches infinity of 3 over the square root of x squared plus x over x squared, plus the square root of x squared minus 2x over x squared. And that's simply writing x here as the square root of x squared, and then separating this into two fractions and bringing the square root of x squared under the square root sign. So that's simply algebra there, and that is the limit as x approaches infinity of 3 over, and now I can cancel this x squared and I get the square root of 1 plus 1 over x plus the square root of 1 minus 2 over x. Now as x goes to infinity, that goes to 0, that goes to 0, and the whole thing goes to 3 over 2.